Okay, okay, thank you, Ken. So today I'll be doing a presentation on animations, time series animation. Uh, Mostly when we are working with the satellite imagery, we normally display the images, maybe the results, either in an RGB format. So when you go into the sandbox or the data cube, what you normally do is you use the load ARD to load your results. And when you load your results, it will come and store it into a certain variable. Aside that, you can also display the results of some of the images that you see. So what you see right now here is some of the images, some of the images for a particular area that was loaded into the sandbox. So it's a Sentinel-2 image and it starts from 2017, like it's a whole stretch of 2017 that has been selected. So normally at the end of the day, after we do our analysis, one of the things that we normally do is to generate a graph to give us a time series analysis of what is happening. So some of the graph is what we are showing here. So with this, you're actually able to appreciate the NDVI value over a certain range that we have. Aside plotting the graph in the platform or on the sandbox, the platform also allows you to create animations of the results that we have. So this is a typical example of some of the animations that you create. So this one was the Landsat, the Sentinel image that was loaded. And we've created an animation of the time series over a period of years. So if you look at it from the date, you can really see that at every point, the image changes. So it actually helps you to appreciate the pictorial view of the area as it changes over a time. The same thing happens with the time series. So over a time, you actually appreciate the graph. But the other way is also have this animation to also give a better clarification of the image you are working with. And having this also makes it easier for your users to understand what is happening. So the DA doesn't only give you the plotting, but also the picture view. As you can also see, this is also another time series combination of the shortwave infrared, near infrared, and the green bands. So this is also another time series for it. And you can clearly see that you've been able to put the title also on the animation. So anybody who reads the animation will actually know that, okay, this is a combination of these things. And DA Africa allows you to do that. So how do you achieve this plotting? The notebook that I'm using can be found at the frequently used codes. So if you log onto your sandbox and you go to the frequently used code, there's one notebook called animated time series. So that's the one I'm going to talk about it. If you've actually followed all the procedure to be able to enable the animation time series within the notebook that you are going to work with, this is the function you will need. So from DA Africa underscore plotting, import XR underscore animation. This will enable the animation function for you to be able to use it to generate the previous imagery time series that we just showed into it. So from the importation, if you've already imported the underscore Africa, the Africa underscore plotting, all that you have to do is make sure that you also add the XR underscore animation to those modules that you have imported onto the platform. So after importation onto the platform, how do you enable it? So there's the function that you use to enable it. That's the XR animation. That's the function that you have to use. From the animation, it comes with the DS. So this DS that I've circled is your data set. So normally when you load from the 6 weeks training, we explain how to load the data onto a variable. So when you load the data, that data is your data set. Then the next one is the combination. So which bands do you want to actually combine? From our previous the previous slide, you notice that you use the RGB. So you can specify the RGB bands here. Then the next thing is your output part. Not only do users actually want to see the results on the sandbox, but sometimes they also want to download it. So the output underscore part will enable you to also export the results that you are going to have. We also have the intervals. The intervals is the time you want the images to be changing. Because if you are dealing with a series, let's say we are dealing with 10 images, how often do you want them to be changing at the time? So and the interval is milliseconds. So if you want it to be changing at every second, that means you have to do it 1,000. That's 1,000 milliseconds will be equivalent to 1 second of our time. So if you want the image, depending on how you want the image, if you want it to be changing every 5 seconds, you change it to 5,000 milliseconds. Then the width pixels. So depending on the presentation, you can also actually adjust the pixels. For the presentation that I was using, I used 300 pixel size for the width, but you can actually adjust it, change it to any size you want, and the system will actually convert it for you. And also have the show test. From the previous slide, you know that the time series animation is a show test. So if you want to add more explanation to the animation, you can use the show test to do it. Aside this, there are a lot of parameters that you can actually use to adjust your functions to make it more user friendly for the users who are using it to appreciate it very much. Then after that, the next thing is to use the plot.close. That will, after everything has been converted, it will close it. And the image, that's the file name, will actually plot it also on the sandbox for you to see the result. So although it will be on the sandbox, if you don't use the image, it's called file name to display it, you won't actually see it on the sandbox. So at the end of the day, you'll be able to see what you've generated. If it doesn't meet the specification, you can go back to the function and go and change it again so that you actually get what you want. And we don't only do it for the bands only. So for instance, if you have calculated an index value, um, that is an NDWI, you can actually plot the animation of it. So this is a sample of an NDWI in which the results will let you know the normalized differential water index over the months of how it showed within the satellite imagery. So it give you the index value and the graph also below it. Sometimes users will also have a shape file that they would like to superimpose on the image. The animation also allows for that. So as you can see, the red symbol or the red diagram that you see in front of the water body is actually a shape file that has been superimposed on the image. And that's also a river body. So having that shape file, if you combine it with the NDWI, you actually also know how the water has been exceeded or if the water is reducing inside. So the animation actually help us. So the animation actually help us to also create another time series in the form of a pictorial view, in which it also give more explanation. If you add it to the graph time series, it also actually help us to give a more pictorial view of the results that we are getting from the sandbox. So this is what I wanted to take the group through today. And from when we are trying to develop products, apart from using the graph, we can also use the time series, that's animation also to generate a good pictorial view for our users and also the decision makers for them to actually appreciate it, because seeing the results in a picture form also stick to their mind more clearer than sometimes using the graph or maybe just presenting the codes and also the figures. So once again, the notebook can be found in the frequently used tool. The name of the notebook is the animated time series. And once you go in there, a lot of examples also in that notebook. If you encounter any challenge or you want further explanation on some of the functions that is there, kindly reach out to Ken and I or reach out to us. Then we will support you to actually utilize this tool also in most of your use cases that you'll be developing. Thank you very much. Before I move over to Ken, please, is there any question?
Not for now, not from my end.
Okay, so if maybe along the way any question comes, you can also put it in the chat, then we can answer it for you. Thank you very much.
Thank you very much,
Over
Edward,
to you,
for
Ken.
this presentation. It's a very nice presentation, and also expanding on what you've presented is that you can use some of these animation to actually communicate with policymakers or senior management people, showing them the power of Earth observation. So it means that some of us are working in different fields. There is for example, as we continue with the introductions, people in the academia, people in NGO, and everywhere working in agriculture, smart farm, etc., etc. So you can use these animations, for example, to show the change in maybe a city over many years, and so on and so on. Also, as we continue, is that we are also joined by Joyce Siundu from an institution in Kenya. Maybe Joyce, you can introduce yourself and tell us about the great work you're doing in agriculture space.
Hi everyone.
Yes, Joyce, welcome.
Thank you. My name is Joyce Yundu. I'm a GIS and remote sensing analyst at Lentera Africa. It's an agri-tech company, mostly dealing with precision agriculture. We are using a Sentinel-2 for crop health monitoring and moisture.
This is a wonderful news, Joyce, that you've joined the group, and I've also put the name of your company in the chat for us and Ogus and everyone to see. Okay. Also, it's very nice that you've joined us. Edward, you can add more about the agriculture stuff we have, crop phenology, vegetation, just to keep the context with Joyce so that we continue with engagement. And also Joyce mentioned that she is registered with the Sandbox, and next week she'll present something, hopefully. So Edward, we have something on the agriculture on the Sandbox. This
Yes,
should be with
Ken.
Yes, my brother. Sorry for taking you very fast. And
No problem. So I think in the Sandbox, we have a lot of notebooks for agriculture. We have the vegetation phenology, which is already there. So we, apart from the vegetation phenology, which actually also have a lot of statistical analysis inside, we also have the crop health notebook, which is also very great. We also have something in relation to mangrove and vegetation change within the notebook areas. So I think with the notebooks, we actually have a lot of notebooks to deal with vegetation. So just as Ken said, Joyce, we can actually look through these ones. And the main goal is also not to have only the ones on the notebooks, but to improve upon them so that it can actually suit most of the needs within the African content. So we'll be happy to go through with you and develop use cases out of the notebooks we have.
Thank you, Joyce, for joining us. This is